Hello everyone. In this session of CCNA series, I will discuss about OSPF, neighbor and adjacencies. In OSPF, the concepts of neighbor and adjacency are fundamental to the operation of the protocol. OSPF routers establish neighbor relationships with directly connected routers on the same network segment. And this is done using Hello protocol. Routers exchange hello packets to discover neighbor and establish communication. To discover other OSPF speaking routers, a router sends multicast OSPF hello packet to each interface and hopes to receive OSPF hello packets from the other routers connected to these interfaces. Hello packet contain information such as the router's OSPF router ID, the network mask, and other parameters. OSPF routers need to agree on certain parameters like OSPF area authentication and other settings to become OSPF neighbors. Once both the routers complete hello packet exchange and each other's information is acceptable, they move to the two-way state. During this two-way state, the routers agree to become neighbors and proceed to the next phase, that is adjacency phase, which is to exchange the data. One purpose of forming OSPF neighbor relationship is to allow the routers or allow the two neighbors to exchange their databases. So the next session we'll discuss is OSPF adjacency. So an OSPF adjacency is a higher level of relationship between two OSPF routers. It occurs when two OSPF routers become neighbors by reaching the two-way state in the OSPF neighbor state machine. Once this adjacency is formed, routers begin exchanging LSAs. Why LSAs? To share the information about their link state and network topology. So here the router, you can see they share LSAs to share the link state and network topology information. So LSA stand for link state advertisement. It is used within OSPF routing protocol to distribute the information about network topology and routes. The process of OSPF adjacency establishment involves multiple states in the OSPF neighbor state process. Let's discuss about OSPF neighbor states. An OSPF transition a neighbor through several states before the neighbor is considered fully adjacent. These OSPF neighbor states are crucial for establishing successful communication between routers and determining the best pathways for data transmission. Let's try to understand the OSPF neighbor adjacency process. When your router is, or when your interface is down, your neighbor state will be in down state. This is the initial state which indicates no information has been received from the neighbor. But once the interface is up, it will move itself to the next state, that is init state. So once the router starts sending hello packet, it moves itself from the down state to the init state. Here you can see Once the router sends an hello packet, it moves itself to the init state. Here you can see in this state the router has received a hello packet from the potential neighbor but hasn't seen its own router ID in the hello packet. In this hello packet, it advertises its own router ID. Okay, so the routers received router ID, but their own router ID is not the receiver's router ID is not seen in the hello packet. So after receiving the first hello, the router sends back the hello by adding its own router ID. This is when the router, you can see, router replies back with its own router ID. The receiver's router ID, sorry. Then it transitions itself to the two-way state. So the router has received its own router ID in the hello packet from the potential neighbor. That indicates that the bidirectional communication is available. Here you can see both the routers adds its own router ID in the scene section and transition themselves to the two-way state. So the next state is the X start state. In this state, actually both routers establish a master-slave relationship to determine who will initiate the database exchange process. Okay, and the neighbor with the highest router ID becomes the neighbor. In this state, as you can see, once it prepares for the election and trying to decide who will become the master, it will move itself to the exchange state. So according to the router ID which we have, the highest router ID is of R2 and it will become the master. And then once the master and slave relationship is decided, then the router will start exchanging the LSAs to build the complete picture of each other's link state database. This is when it moves to the exchange state. So once all the LSAs are exchanged, it will move to the loading state. In this state, if there are some missing LSAs, for example, the router will request that missing piece of information by using link state request packet or LSR. And the neighboring router will respond with LSU, that is link state update packet. Once the link state update packet is received, it will respond with link state acknowledgement packet, that is LSAC. So once all this missing information is exchanged, the router will move to the full state. Here the routers have synchronized the link state databases and are fully adjacent. They can now exchange routing information and accurately calculate routes. The successful establishment of OSPF adjacencies is crucial for OSPF routers to operate effectively and provide accurate routing information. If there are issues with adjacency, it can lead to suboptimal or incorrect routing decision, affecting network performance and stability. That's it for this session. I hope this was informative for you. Thank you for watching, and if you have any queries, please do send me an email or ask me anytime. I'll be there to help you. Thank you.